4x congruent to 1 modulo 105. Last time, we saw that one way to do this is to try all the multiples of 4 as we keep going and see what they are modulo 105. If we try to do this, though, there are a lot to check. 4 times 2, 4 times 3. 4 and 105 are relatively prime, so this will finish at some point. 4 times 104. This is a lot of work. Let's start this job. 4 times 0 mod 105. Well, that's 0. 4 times 1 mod 105. That's 4. 4 times 2 mod 105. It's 8. 4 times 3. I don't even feel the problem of the 105 yet, because my numbers are so small. I don't even need to divide by 105. It seems like I will spend a long time before I even reach 105 in the first place. What that means is that there might be a faster way to do this, where even though our question was about multiples of 4 compared to 105, it could be faster to think about the 105 first. You see, if I'm going all the way down here, there's a question I ask myself, which is, will I reach something that's right after 105? Will I reach 106? 106 is the first thing that I could possibly hope to reach, which is 1 mod 105. Well, let's check. Is 106 divisible by 4? It's not. The easiest way to check divisibility by 4 is that the 100 is already a multiple of 4. So all I need to do is check the last part, whether 6 is divisible by 4. And it's not. What this means is I will not run into 106 first. Something I want to note, though. I said this is not a multiple of 4. But I will write down that this is 2 mod 4. Actually, I should also say there was another one I should have checked first. Another multiple of 105 plus 1. See, these are 1 mod 105. The first one, which is 1 mod 105, is actually just the number 1. And I should have first asked, will I see 1? We didn't ask that question because it was very obvious we wouldn't see 1. We already didn't. But I'm still going to write down, we should have checked whether this was a multiple of 4. Well, it's not, but it is 1 mod 4. What is the next one that I might need to wonder about? The next one I might need to wonder about is 2 times 105 plus 1. Because that's the next opportunity I have to get 1 mod 105. Is this a multiple of 4? No, that's not a multiple of 4. But you can already see what's happening here. What is this? What is the remainder of this when I divide by 4? I will be picking up 2 from the 2 times 105 plus 1. I will get 3 mod 4. And where this 3 is coming from is really, this 105 is 1 mod 4, because 104 is a multiple of 4. So this is actually 2 times 1 plus 1 mod 4. Well, my goal was to find one of them that is going to be a multiple of 4. I see 1, 2, 3, so I know the next one will work. The next one, the last one, would be to check whether 3 times 105 plus 1 is a multiple of 4. Well, this time it is. It is because 3 plus 1 is what it becomes. It becomes 4 mod 4. And therefore, I just have to figure out which multiple of 4 it is. 3 times 105 is 315, but plus 1 is 316. So now I just need to divide it by 4 and see that that is 4 times, dividing 316 by 4, 4, 7, 28. I have an extra 3, 36. 4 times 9, 36. So it turns out that 4 times 79 will give me 1 mod 105. Why did I do this example? This example is showing that there are two ways to approach a question like 4 times something congruent to 1 mod something else. One way is to keep going by multiples of the first number, the 4. And if I keep going by multiples of the 4, what's the most I'll ever need to check? Well, it's the other number. If I go by multiples of 4, I check up to 105 times. The other way is to flip it on the other side and say, I will instead check multiples of 105, and I will have to check at most 4 of them. I'm showing you a symmetry. There's a symmetry between these two, the 4 and the 105, in that you can solve the question either by going by 4s or by going by 105s. And the number of things you need to check in one case is the 105, and in the other case is the 4. So if you're doing it this way, you should cleverly choose to go in the way where you check the fewest. In this case, that's going by multiples of the large number, so that you only have to check 4 of them. Why am I spending so much time on the symmetry? Because if these two are somewhat symmetric, this suggests that there might even be another way to do this problem, which handles both the 4 and the 105 at the exact same time. That method we'll focus on next.